Hello guys, welcome back to my YouTube channel .NET-Dev-Journey with Jacob, and today is the day 9 video of my journey to becoming a professional .NET developer. In the previous video I spoke about exception, and today I'm going to be laying more emphasis on exception and how to handle it with reference to my simple banking project, which I've been, talking about and showing you guys and what I've done so far um, with the program. So today I'm also going to be making another short video to tackle the error or the bug that I discovered in my program, in my code yesterday, the email validation bug that was discovered. So I'm going to be doing another short video to show you guys the research you know, I carried out, and how I came to understand the process and what I've done to undo that bug. And I'm going to be showing you guys live because we are going to be doing that together. So yeah, let's quickly um, dive into today's topic. And before we go into exception, we need to first understand what an error mean in the programming parlor. So error simply means anything um, abnormal behavior that could interrupt the flow of execution of our program. So excuse me. So it implies that exceptions are errors, abnormal behaviors. It could be expected, it could be unexpected, that a program encounters during execution, and it could interrupt the path of execution of our program. So there's a need for us to be able to handle any error that comes or any exception, so to say, that a program encounters. So we should prepare for it, and we should be able to design a system that can manage whatever exception comes up. And just like I said, we have two categories. We have expected exceptions and unexpected. The unexpected ones are the ones that does not occur, that does not usually occur. They are not frequent. It could be once in a while, but there's possibility for it to occur. Maybe when there's a change in environment, or maybe there's a connection change, or uh, maybe there is permission issue of writing or reading from a file from a DB. So these are some of the things that could happen for the unexpected exceptions. But for the expected exceptions, it could be maybe user entry, maybe where the user is supposed to enter their names, they are submitting an empty field, or peradventure um, a user forgot to enter a required field. Um, Or take for instance, let's say if an accounting or a financial software, and a customer wants to withdraw from the account, and the withdrawal could throw the balance into a negative, value if the amount to be withdrawn is more or higher than the balance. So these are, expected ex exceptions that could occur. Or peradventure, maybe a customer is trying to deposit a negative value, or maybe zero. These are some of the things that one could label as expected. And there is a need for our program to also be able to take care of those things. And one thing I want us to also know is that exceptions are very expensive, and that's why .NET has also come up with different method of simplifying the handling of exceptions. For instance, to be able to handle exceptions where users are supposed to enter integer values and they are entering string values. You see, instead of the normal try catch. Okay, let me show us this. So for instance, the normal way to handle exception in .NET is this is the structure here. So do catch, say exception, maybe E for example. So we do this and we have finally block. And we have this. So here, the block of code that could, run into an error that could throw an exception or could cause an exception is what will be in this block here. Code that could cause an exception or error, as the case may be. And here is control of the exception. So this block of code here will help us to handle the exception that has been, thrown by the block of code here. But this finally is the code that is expected to be executed regardless of the exception. Regardless of the exception thrown. Regardless of the exception. So here we have the block of code that could cause an exception to occur. Here we control how the exception is being handled. Probably maybe we want to display a user-friendly message to the user and not the exact exception stack trace. Um, yeah, and here is just the finally block is where whatever code we still want to execute regardless of the exception. So for instance, maybe we want to free a resource that has been locked, or maybe we want to close a DB connection, stuff like that. We want to release a resource. So those are some of the things that could be in the um, finally block here. So this is basically by default how it is being handled. But .NET has also made another way of handling exception, a more lighter and simpler way, because exceptions are really expensive. And here we have, you could see int.tryPass, we have datetime.tryPass, we have float.tryPass, we have double.tryPass just to be able to handle user input. So here it simply helps us to, to filter the user input to see if the input can be taken as integer, and if not, it displays this information to the user that it is an invalid entry. So the user has to enter a valid entry. So these are some of the things that helps to is a light form, a light way of handling exception, and it is less costly and less expensive than trying to use a try, catch, and finally block. So yeah, having said that, let's go back to the program here. And if you look at um, my customer class, you'll see that it's a bit messy, and I intentionally left it like this because we are going to be working on it together to see how the whole thing will be cleared. Because one thing I mentioned in the last video was that uh, there are boundaries for which exceptions are handled. For example, in a proper application that have a clean architecture, separation of concerns. So if we take this for example, we have the domain layer, we have the application layer, we have the infrastructure layer, the presentation layer. So for the infrastructure layer, which is the repo that is the repo aspect that has to do with the contracts, it has to do with the DB connection or file connection or whatever it is that we are using. So here is where we could use the try catch. Here we could throw, no, I beg your pardon, not the try catch. Here we can throw exceptions. Because take for instance, if we want to handle, let's say we want to handle file connection. So for instance, handling of file connection could be in, let's say, yeah, could be in a could throw an exception. And why is that? Because, for instance, if the DB for one reason or the other could not be connected to, it should throw an exception, letting us know that this is a serious issue. Or peradventure, if the program could not have access to the file or could not write the file or read from the file, these are serious issues, and that could even affect the trust of a customer. And these are very, very, serious issues that needs to throw exceptions. So we throw exceptions in the infrastructure um, layer, but in the domain layer, yeah, we throw exceptions too, but we need to manage the way exceptions are thrown. And instead of throwing exception, we can use a result-based operational outcome for the domain. What I mean by result-based is that instead of throwing exception, we could define a class that could help, throw or return if an operation is successful or if it fails. So rather than throwing exceptions, because if care is not taken, exceptions can also be abused. So in order for us not to abuse exceptions, so we need to look for a way to, modify this class to be able to reduce the throwing of exception. But before we go there, there's one thing that is called invariant. And what invariant simply means is invariants are the conditions that is needed to be met for an object to be considered valid. So for instance, this is a class of customer, but from this customer class, we could create a customer object. But for that object to be valid, for the customer object to be valid, we have some invariants that needs to be met, some requirements that needs to be met. And some of these requirements is the last name, other names, the date of birth, for instance, the email. These are things that need to be met, that needs to be conditions that need to be satisfied before the customer can be referred to as a valid object or a valid state. So what then is a invariant or constructor invariant or invariant constructor, as we might want to put it. So these are uh, the points of entry of creating an object. So the the constructor invariant has to be satisfied, has to be valid before the creation of the object. Because at the point of declaring this customer object, then the invariants are supplied, the argument is supplied into this customer because it has a primary constructor. So at the level of the primary constructor, the invariants are checked to see if they are satisfied before the customer object will be created. Else, it should stop the object from being created because if that's not the case, it is possible for us to have object, an invalid customer object, and this invalid customer object, once it is allowed to be, created in the system, this same object can be passed around different sphere of the application, and it could lead to error, it could lead to false outputs, it could lead to a lot of issues. So there's need for us to ensure that our objects are valid even at the point of creation. So now, in the last video I spoke about protecting the class or the objects, as we might want to put it, either way, either a class or the object, because the object is formed from the class. So now, the object is an instance of a class, I mean to say. So now, if for us to be able to ensure that the object is valid, then the the conditions must be met. And there is need for us to be able to set those rules because it is those rules that will help us. We can't rely on uh, the validation of inputs at the presentation layer or presentation level. We can't rely on that. So we must be able to declare the set of rules that will guide the formation, the creation of our objects. And to do that, we're going to restructure some things here. So here I used a primary constructor, like default constructor, but we are going to be changing that. So here is what we are going to do for today. We're going to be using protected customer, and here we are going to declare all this. So I'm moving this into this part here, and here we are saying customer ID is equal to this. So just follow along. Then last name is equal to last name. Then other names equal the name, and date of birth equals this, then email equals email. What else? Okay, yeah, that's all. So what we do from here, remove all this, remove all this. The reason why we are doing this is we want to first ensure that our parameters, our invariants, the conditions are satisfied. before we assign the values. So here is how we want to throw our exceptions, because here this is a defensive mechanism. They call it is referred to as defensive mechanism to defend the the creation of customer objects, so as to ensure that it is only a valid object that is created. Once it detects any invalid invariant or property, it rejects it. It fails at that level. So we are saying if string dot is null or white space last name, if this, then we are throwing an exception. So we are saying new argument exception, not argument null. Then here we are saying last name required. So let's just copy that to make our work faster. So here is for other names. And here we are saying other names required. Other names. So we are refreshing the other names field there. And then we are saying if how do we do for date of birth now? Because for an account, do we restrict it to 18 years? If date time dot bypass, if not the time dot try pass date of birth, not right days. I'm trying to see what could be the possible. Okay. Let's say date time results. Okay, that's only. Oh, if that's only Not try pass. Let's see if this will work. Okay. Let's only results. So working as a string I format are provided. Output only results. Okay. Should be output only results. Mm, okay, let's see. If it's not should be daytime. Oh, how do I validate this? Okay, let me do for email, then we'll come back to that. Mm, let's do for email first. Email required. Email address required. Changes to email. Then if date, um, if date, okay, let's say if date dot equal new dates only. I'm not sure, I'm just trying something here to see if this it's only intro argument exception. Let's say dates of birth required. So I'm just trying this. I'm not sure if this is the right way to handle the exception for date of birth. But you can, if there's a better way, please let me know in the comment section. Yeah. So I think I might be adding maybe to check if uh, to check that the age is 18 and above, but that will be later. So I'm still going to be updating and committing these changes to my repo. But for the sake of this video and to keep it short, we are 30 minutes into the video already. So I want to make it snappy. So let's just get along together. So what we are doing is we want to first check that at the point of creating the object, we are checking that these invariants are valid, the conditions are satisfied, they are not empty, they are not, the input is accurate and is valid, and then we proceed to, creating the object, because once all these conditions are satisfied, then we can have a valid customer object. And that's why we change the whole thing here. And down here, we say link account number. Okay, yes, this can still throw, um, this can still throw, what's it called? An exception. Yes, can still throw an exception. So what else? Email address. Email address. Email address. We need to be sure that these are valid as well. Okay. So let's do something. We can use the results type here. Let's change this to results instead of throwing off, because we need to send back uh, an output. So I'm going to show us this result. There's a class that I created. You can see hero handler. That's the name I gave to it. So I created a class. What this class does is it sends back, a message to say whether an operation is successful or not. If it is successful, it just returns, a bool value to show that it is success, which is true. And here we can see we have public bool is success, public bool is failure. Is failure means that it's not success. So when we have error, like a string error to show, to tell us what kind of error that the program has encountered, to give us a feedback of the kind of error that the program encountered. And here we can see it has two static method. We have the result success and the result failure. So this just helps us to know if an operation is successful, we return success. If it fails, we return failure. So that's just what this class does basically. So let's go back to the customer class and see how to implement that. So here we could see we are having error. So let's just use the namespace. So yeah, we have introduced the namespace, and the reason why we are trying to use this result is because it is possible for this. We want to ensure that this invariant too is is not empty, or So what we are going to do is we are coming here, we are copying this, but instead of throwing an error this time around, we won't be throwing an error. This is what we'll be doing. So if string new last name, so this will be new last name, new last name. So we are saying return results dot failure, and we are going to be passing in the error message. Last name for updates is required. Valid, a valid last name for updates is required. So, but if this is not the case, then proceed to change the last name, then we return results dot success, and there we have it. So we are doing the same thing here, but this time around we are changing it to so we are removing this. We are putting it here. So we are using new email address here, and then we are saying a valid email address for update is required. And let's just say valid email address is required. So a valid last name is required. So here we can see that for these places we have a result based exception control, and here we have our defensive mechanism for ensuring that our invariants are the conditions for invariants are met for us to have a valid customer object. So you see, it helps us to limit the way we make use of the way we throw exceptions. So here is not the best view. We might not see the usefulness as such here, but if we go to account domain here, let's see our account domain for instance. You could see I've refined this one as well. I've changed it to this. It was using a default primary constructor before, but I shifted it just to be able to have a good and solid defensive mechanism to ensure that we don't have an invalid object. So, and here you can see the results um, based error handling here. So we can see it is more pronounced there. The error handling is more pronounced there than the others. So as you can see here, we have it, the error handling. So we return error.success and all of that. So we can go to, let's say, application layer here to see how that, okay, let's go to customer profile first and see how that applies here. So here we are saying variable customer repo get customer by ID. And if we open our customer here, what are the things where we use the results? I think we use it in the change last name and change email address. So if we go to account status, I think that was where we use the change. See here, customer profile. Okay, updates address, updates this. Okay, here. So in this place here, we could have something like let's say var results is equals to customer dot change last name. So here we are saying if results dot is success, or if result dot uh, if result dot is success, okay, if result dot is failure rather, dot is failure, then we are saying return should we say return results? I'm trying to see how we should deal with this. Okay, we can say if results dot is success, then we have this else. We say what's this thing called? Or something as the user inputs outputs. Okay, there was an example I used in one of the video. Okay, show exception message. Yeah, so we say show as user input output show exception message. Then we say results error. So we say results dot error. Error result dot error. That's what it's supposed to print. So I don't want us to use like the return because we can make this result as well to get results, and we can display the results. We can just say yeah, this is just probably better. So we can handle it this way, or we can find another way to handle it. So I'm just showing us how the result based stuff works. So okay, let's try something together and see if that is going to work. Oh, this is 44 minutes already. Uh, Okay, let me see if this will work. There's something I want to try here. Customer string activities protection level. Oh, okay. Uh, it should be public customer, not sealed there. Public customer. So let's run and see. We're going to run into any error. Okay. There is something 7 update last name. Oh, sorry. And I've changed some things in the customer settings as well. So, okay, let's just go with new accounts. Last name Jamie Fox. Let's say 1990. No, it's um, Fox. So this was what I was saying that about the email. You see, he accepted this, which is not supposed to be. But we're going to come to that in the next video I'll be making to explain how I was able to how to handle that anyways, because I made some research and I was able to make an headway regarding that. So we have invalid entry, try again. Uh, Invalid entry, try again. So it's not accepting that. So this is at the presentation level anyways. Okay. But you all understand what I'm trying to do here. But I'm going to be showing us a holistic test of this whole system. By the time I finish refactoring the whole code, making it simpler, because if you look at this program, um, the entry points here, you can see that it's a bit messy. I've got a lot of lines of code here, which is not supposed to be. So I'm going to be taking care of this to make sure the lines of code are shorter because they shouldn't be as much as this. So I want to ensure that I take care of everything. But for now, I hope you're able to understand the result base, um, trying to eliminate the throwing of exceptions as much as possible. So I'm limiting and I'm keeping the um, throwing of exception just at the invariant protection level. But aside from that, every other level, I'm using the result-based um, operation error handler. So I call it a result-based flow of control, error-based flow of control. So yeah, that is what I call it because it helps me to handle the flow of error control in this program or in this project, as you may want to put it. So in this next video, I'm going to be showing us how to handle the email issue. Thank you and see you in the next video.